Hi, I'm Krishna. We are from Mash Energy APS Denmark, which is a company that is producing modular machines for gasification and pyrolysis. So the basic background is how can we use bioenergy for going from point A to point B in a sustainable manner. And I will be presenting about what are we doing in getting this thing done. Denmark has a history of a good reputation in clean tech sector, and over the years has been developing um, uh, various technologies for biomass processing, whether it is gasification or pyrolysis, and all of this has a common thread, which is production of biochar, which will be a part of my presentation. And we are a spin out from DTU, which has a good research group and a lot of work going on in this domain. And we spun out around 5 years ago from technology that was being demonstrated for the last 30 years. And so basically the idea is that there is a big share of carbon emissions for a shipping company like DFDS, and 90% of its emission is from the shipping itself. And then this is a big problem for all environmental reasons and for global warming, etc. Now we have been trying to commercialize this machine, which was built several years ago and has an equivalent runtime of 14 years, which is called the Viking Gasifier or Viking two-stage gasifier. So this machine has, if you can see my cursor, has a pyrolysis screw and followed by a gasification chamber. So, and this machine was implemented at different sizes, like 20 kilowatts, 200 kilowatts, 400 kilowatts, and it has various good properties, such as the tar is completely combusted in the machine by a partial oxidation, and because of which we are able to recirculate a big amount of the heat, and therefore has a cold gas efficiency of 93%, which should be a good percentage. And now this basically then works as a technology platform in which we can use various things, like this machine can be used for district heating production, biofuel production, electric power, gas productions, and then the gas that is produced is primarily hydrogen. And yeah, so there is this platform, but this platform, sorry, just a second. So there is this platform with which we are able to produce a gas which is primarily composed of hydrogen, carbon monoxide, carbon dioxide, and nitrogen if it is air. If air is injected and if oxygen is injected, then it is primarily the three: hydrogen, carbon monoxide, and carbon dioxide. So everything else like methane, etc., are broken down into the system. And all of this, we have a thing called a char bed. So when the feeding is done, it goes through a pyrolysis screw, and then the char falls down, and in this area we break down all the tars. So the char is actually working as a filter, where we are making the filter and we are continuously using the filter to remove the tar. And we are also having some moisture. So when this is at super hot temperatures of around 1000 degrees Celsius, then the water that is going through this line is also activating the char. And then we have a line that takes the gas through this chamber and goes through the jacket of this pyrolysis reactor, where the pyrolysis reactor is heated, and then the rest of the heat is recirculated through some air-to-air heat exchangers. This is a system technology platform with which we are working. Now, what are we actually ready with, or what do we actually do is we do some pyrolysis to produce some biocrude, which is just pyrolysis, and some gasification to produce electricity. These two products are in the running state. They are built and they are in modular containerized versions. And we in the coming time want to make hydrogen production and methanol production and other things. And the common thread in all of this, as I said, is the char production in with it. Also, I wanted to say that this kind of machines that we are working on provides a good platform for power to X projects, which is something that is of big interest in Denmark right now, where the excess power from wind, etc., is being considered to be converted to methanol and hydrogen gas and ammonia and other sustainable fuels. But the bioenergy also can produce that. So if you see the gas composition that we get out when it is in oxygen blown environment, it is a big share is hydrogen, and we have carbon monoxide and carbon dioxide, which makes it a very suitable gas for further steam reforming and using pressure swing absorption for hydrogen production, or with other techniques for producing ammonia and methane, because ammonia and methanol, which are which makes this system something that can not only produce heat or produce electricity, it can produce a gas which can be used for producing chemicals. The other interesting thing that we are working on is we can actually use surplus energy from like wind or some other source and use it in a pressure swing absorption chamber to basically extract the oxygen from air, and that requires some electricity, but then we get a much better quality gas. So in air we have a big share of ammonia, and if we don't have that air, then the quality of the gas is much better. So our principal focus is to basically get these machines working, troubleshooting the machines, and in this process we are producing a lot of char of different qualities. Some of the chars are activated, in some mechanisms, if we just run the pyrolysis machine, then we are not activating it, but when we are running the gasifier, we are also using it as a filter that is being continuously made and continuously being used to further break the polyaromatic hydrocarbons and the moisture in the machine to be used in this char in the gasification zone to activate the biochar. Yep, and then this is getting these machines in modular versions and producing and running them efficiently with high energy efficiency is the core thing that we think is very important, because biomass in general has a very low density, and therefore the transportation cost is very high. And if modular machines can be made, then they can be used locally and in a distributed manner. And there is this saying that this can like replace crude oil with crowd oil. So the crowdsource, people can produce methanol and oil and biochar from this system. Now the system has interest from ferry companies like DFDS, who both are interested in the oil sides of it, but also in the char, and is actually interested in a good combination of the two. And that is so there is interest of this thing we see commercially. Talking about the properties of the biochar, we think is completely dependent. Like when we have a machine where we have Arger type screw conveyors, we can run it slowly, we can run it fast, we can keep the temperatures high or the temperatures low, and it all depends on what we want. And in the modular version, we are running 8 tons per day, and we are doing trials of that size. And then if we have a high filling ratio, so some of the screws have to be run faster and some of the screws have to be run slower, then we are able to have a high residence time, which means that the quality of char should increase. The carbon content or the volatile content in the biomass decreases. Some of the biomass actually also does not have a very high volatile, or large amount of volatiles do not come out after temperatures of 600. So it's more actually to get high volatile fractions. We actually work more on getting all of the biomass heated instead of getting some of the biomass to reach 900 degrees Celsius. That's one of our observations. In these screw type machines, we are able to observe that the char that is coming out is of very high calorific value. So it's around 28 megajoules per kg, or and yeah, and again, the ash content can be very low, but again, if the biomass has a high ash content, we will have ash in the system. The system again we can work with different moisture contents, and in the end the system the biochar has a tendency to absorb some of the moisture when we have it in large scale, which there are obvious ways to handle it, but there is no smart way to handle it so far. When we run it in the two-stage gasifier mode, where we have the gasification chamber, then the moisture actually, when it runs through the char bed, it is able to increase the surface area significantly, which is another good property that we have. So this is basically the specs, and people who, I think a biochar audience will understand the pros and cons of the specs that we have. But yeah, in general, what I'm trying to say from these specs is that if you are using a screw pyrolysis machine in a modular version running around 8 tons, it is possible to vary the parameters and produce char of different qualities. And it is possible to still run and produce oil and run the machine in an energy efficient manner. And it need not be a very big machine, like physically like a very huge machine, and one can get very high energy efficiencies. So this is what we do. Then there is this thing that when we have this biochar, then we have been doing some field trials of biochar using the agricultural field. And based on that, we see that if one can actually reproduce the terra preta type biochar thing, then there is this additional benefit that if the machine is energy efficient and if the transportation costs are low, then even sold, then it actually becomes a very carbon negative process. So, and it's not a little bit carbon negative, it's the first carbon negativity is because of so there is various angles to this whole. The first carbon negativity is because that the biochar can capture carbon because the moisture and the nutrient retention time in soil is low. And this is where I'm talking about acidic soils with like really bad soils which are acidic and which have low organic content. That is very important. In those soils, we observe that the moisture and the nutrient retention time actually is a cause of a lot of carbon emission. Like if somebody is operating a diesel pump, for example, to just flood in a lot of water, and the biochar can reduce it significantly. The second factor is that we, in this process, as in all biochars, are recycling the phosphorus. And when these soils are phosphorus deficient, so when one atom of phosphorus is recycled, it enables 116 atoms of carbon to be captured, which is called the Redfield ratio. So that also plays into the negative properties, making the biochar negative. The third property is the carbon CO2 saving through carbon sequestration. So the carbon sequestration is not just because of the carbon itself in the biochar, but also because of the because of the increased growth. So if we are taking an acidic soil where in general agriculture is not happening, and if we are putting biochar, then we are assuming that it should like we have done trials for one season, but if it is to be implemented for multiple years, then each year when there is a crop yield, it is capturing new carbon. And when something like corn or rice husk is growing, then that rice husk or corn is now capturing new carbon, and that plays a big role in the overall sum, which is this carbon coming from the sequestration. And of course, then that biomass can be further used for processing and producing more biochar. But it is in the first place capturing carbon. And the fourth place that we see biochar plays a very big role in our overall calculations is the oil displacement. And this oil displacement is the oil that we are producing. So some might think that the biochar, why we should focus so much about the oil, because it plays a good important role in the overall equation when we do the life cycle assessments. And these are something that people who want to use the fuel, they care about, because if they can show that there is a life cycle assessment which shows that there's a big capture in carbon, then it's a big plus. So basically, the idea here is that we can produce 1 barrel of additional oil, and then we produce a lot of biochar. This biochar is then being used in capturing carbon in one and more than one way, and increasing the soil fertility and the further capture through um, through the growth of the new corn plants or the new rice husk, that is further capturing the carbon and reducing water retention and all of that. And then we can replace 8 barrels of oil with 1 barrel of oil that is produced, because then that barrel of oil also produces the biochar along with it. So this is what we um, this is quite important thing that we find from a commercial point of view. We do work with a lot of different pyrolysis reactor, and we do not have we do not have an opinion that this is the type of pyrolysis reactor to be used. And we do modular versions, we do bigger versions, smaller versions. These are mostly different projects. Some are like demonstration projects, some are UN projects, some are EU projects, or some alliance like Indo-Danish projects or different things like that. So we are doing a lot of projects of this type. We are making machines of different kind. This is like a 3.5 ton capacity oil production capacity machine, which is carbon negative, which was implemented successfully as a UNIDO project. It is in Tanzania. This machine was implemented. It has a furnace and it has 3 screws, as you can see here, and then a feeding system, and in behind you have the condensers, which is condensing the oil. So so it is possible to process a lot of biomass in a relatively small machine. That is one of the things I also want people to get. What do we do and how do we do? So this is more or less the pyrolysis machine design. So basically, we have a 2 airlock system, and then we have 3 screws working one after the other, and 2 airlock system thereafter. And then the gas is just, there is the reactors, and then there is the jacket, as we call it. So a spiral going around the reactor, and the biomass just goes through it, through this chamber. And from here, the gas is injected, the combusted gas, the hot flame is injected, which circulates along the jacket through the system and is extracted from the top, the exhaust heat. And then again, the exhaust heat can be used in district heating or something like that. And the gas is introduced from here, and the gas is taken out from the system, run through a cyclone, and again, depending on oil production or what we want, if we just want heating, then we can then circulate it back into the a burner, and we can get all the heat out from here. If we want to produce it with oil, then we have to have some condensers thereafter, and the rest of the gas can be used in the engine. The engine produces some electricity, and the unutilized gas can be then circulated in a steam dryer, where an air-to-air heat exchanger is used and nitrogen is used in this chamber. So these are different methods with which we are. This format seems to work well in the large scale, because in large scales, like when we are operating a machine with 8 tons, many good ideas don't end up working that good. And so it is very important for somebody like us to know which is actually working and which might work in the future. So our main objective is that this is something that we are working a lot, but they are still like in project level. The oil that we are producing has remarkably good properties. It is ISO compliant on most specs, and is being further, the oil is undergoing marine engine testing and boiler testing. And that is, I think, as I was saying, is a big part of our work, is that the machine must work on both ends. And if it is not working on both ends, it's not it's not feasible to run it in the longer term. So this is and what I'm trying to say is that the fuel that is coming out from a refinery with big machines, it is possible to produce the same fuel from a pyrolysis machine, and while producing the biochar, and the machine being fairly small and can fit in a container. Then this is the other machine that we were talking about, is when we have the pyrolysis followed by the gasification chamber. In this case, we have the big screw behind that you see is the pyrolysis screw, and then this gasification chamber where we have the partial oxidation, and then the char bed. In this case, the char quality is much better. There is an activation of the char, and it can work as an activated carbon for more than one uses. and then again the gas is taken out and recirculated into the system, and the char is taken out in the opposite direction. So we are also able to utilize all the heat, and we are able to do these things because the main issue with running big machines is how do you avoid the tar formation, and how do you avoid the tar formation, and how do you can recirculate all the heat that you have been using in heating the biomass. Because when we have heated the biomass, we have a hot gas and a hot char, and the hot char and the hot gas are of no use. They have to be cooled down so that water can be removed and things can be done to it. It can be put in an engine, or it can be put in some methanol reactor or anything like that. So this is more or less the work on the gasifier. This is again containerized, and it can produce 80 kilowatt of electricity and 150 kilowatt of thermal heat. Research opportunities, we are still a big part of our work is doing research in EU projects and other projects. We see that the biochar itself can be a very good source for carbon capture, like additional carbon capture from coming out in form of CO2 from a machine. And this is something where the whole power to X section of stuff, like if there is a big biomass power plant, which was earlier a coal power plant, now replaced to a biomass power plant, they are we can supply a lot of biochar to them if we could do this thing right. The soil amendment, again, we are doing some work, but again, the experiments take here a long period of time. So we are looking for people who can help us with that. The third is construction material and compressive, like using in steel and other places, or in the construction industry in general. We understand with our bio oil, with our biochar, that they have good properties, but that's not enough. Even though we are producing in large amounts, that's not enough to sell it. And these demonstration projects with people who understand these fields more are very important, and that is something that we are not able to do right now. What we do beyond that is we provide a simple service. If anybody has any bio waste, we can take the bio waste, we can process it in a small machine, we can process it in a big machine, we can produce a lot of biochar. And if somebody can demonstrate us how to run it in a metallurgy industry or in a construction industry, it will be very useful. From our end, we are able to our machine is very flexible, so we are able to produce biochar of various different qualities. Uses, the briquettes is the only use, or like heating it, a direct replacement to coal for just combusting it, is the market that we have right now, which works. People are happy as long as it is burning. People don't care if it is, but this is people who don't care if it is coal or if it is bio coal or if it is charcoal. Other more attractive industries like the metallurgy industry or the building construction industries, or and the soil amendment or activated carbons are things which we read a lot about, we want to do, but we want to do large scale demonstration projects with people who have maybe lab scale or pilot scale, or actually the know-how expertise on that domain. And that's something that we need to do, so that we can really utilize the whole value chain. And that is a big bottleneck in this type of machines that we are working. And yeah, we are a team with some people from DTU, some people from the industry, and some international people, and some research groups from DTU. Thank you. So that's more or less my presentation.
Thank you very much, Krishna.
Was I on time?
Yeah, perfectly on time, actually. 2 minutes early, I think. Okay. So very nice insights from a more commercial perspective this time. So for the audience, if you have any questions, please write in the chat or unmute yourself and ask directly if you want to. Or otherwise, I will start with one question I would have. So for your biofuel barrel scenario that you showed, that you can replace 8 barrels of crude oil. So what's your current price comparison for your pyrolysis gasification reactors? Are you somewhere comparable to crude oil, or?
No. Okay, so on this, I think the The oil aspect of things is that the way pyrolysis oil should be compared is not with other crude oil. Uh, that's not a thing in the industry. Like take any startup. I'll give you an example. There is a company called Good Fuels, which started a few years ago. They do vegetable oil based transesterification to produce oil which is used in the industry, and then they also do hydrogenation, but technically it is from vegetable oils. And then but for a shipping company it doesn't matter, it is oil, it is bio oil, and it works. Now that oil and a few other other oils from maybe from transesterifications, these are typically sold in a blend. So it's like a B10 blend or a B20 blend and B50 blend, and the price of the oil segment will be a lot more. And then the pyrolysis oil has to be competing with that price because there is a buyer for it. And then the main constraint for the buyer is that, has your oil gone through the marine engine test? Has your oil been tested for the ECN, the combustion values and the ignition delays and the marine boiler tests? And those validations, if somebody wants to produce pyrolysis oil, then based on our analysis, I've been in this thing for 8 years trying to sell oil and trying to produce oil. I think we should not, the better way to go is to get for more validation and then work on the price, because then only one can get a price that somebody from other similar output but different technologies are able to get.
Okay.
And on the electricity, there is a clear benefit of producing bioenergy. There is the prices just from the government regulations in many places electricity prices are high if you produce it from a biosource.
Thank you. We got one more question in the chat. Is it possible to get representative char samples for analytical testing? So I think he is interested in your 2,200 square meter per gram biochar activated carbon.
Yeah, we would be happy to. We have a lot of biochar. As we told you, the only thing that we do biochar is we sell it and not even say that it is biochar. So we have a lot of biochar. We will be happy to produce like 5 kgs, 10 kgs, 1 ton, 5 tons, whatever people want.
But also in the gram range, like 100 gram.
A gram range, yeah. Like anything, like we have a factory and we are producing oil and we know what to do with the oil. The oil goes to alpha level for a company in Denmark who makes these marine boilers, and they are testing our oil. On the char, we just find a local trader and just sell it like it is charcoal or it is coal. Just don't talk about it. But so there is a very big gap, I would say.
Hi, Krishna. Hello. Am I audible?
Yeah.
Krishna, I've got a question. Like you told, this purpose of this oil is to power ships, so as a biofuel for shipping industry. So there is a lot of research in this area, and now there is also one more competing fuel, like ammonia, is being thought as the future fuel for shipping industries. How do you compare your fuel competing with ammonia in future?
Yeah.
As a shipping fuel?
Yeah. This is an interesting question, and I will give you an answer. So when you look at the what is possible from what we know is possible, and I'm sure there are people who know it better, but when we do gasification, then we are able to produce this hydrogen rich and nitrogen rich gas, and we, as in somebody who is producing this gas, can then supply it to somebody who is making the reactors that are producing ammonia, because they are also using a pressure swing absorption techniques to basically, they are taking power. They have a machine in which they've taken air and they take nitrogen out and oxygen out. And they have electrolysis where again, they are taking power and they are taking the hydrogen out and the oxygen out. And then the nitrogen and the hydrogen are put in a different machine to produce ammonia. Now, on this level, these gases are interesting for them. We are not having any projects on it right now. We are only having projects where people are willing to say that this is interesting, but we are not having exact ammonia production from gasification processes. But having said that, whenever this oil is produced, this oil for a shipping company, the thing that matters is that what are they emitting. And it doesn't matter if it is a bio oil or if it is a crude oil or if it is anything else. They are emitting carbon dioxide. Even methanol, if you are using, if they are using methanol, they are emitting carbon dioxide. And they're strict. If there is a, like in Denmark, there is a carbon tax. The carbon taxes don't go down. You can get good PR, you can get other benefits, you can maybe trade it in the voluntary carbon market, which is a very important thing in a efficient machine. But nothing like no bio oil, no crude oil will be making a ship company carbon neutral. Only ammonia, because it will produce nitrogen, or hydrogen, which will produce water, can make it carbon neutral. And gasification is a method through which that can be done. Comparing it to other techniques, the other techniques are basically take a lot of wind and then convert it to electricity and then use that electricity to produce ammonia or produce hydrogen, which is, one is electrolysis, the other is electrolysis and pressure swing adsorption combined. And there is a very big industry demand for this power 2x, the wind to chemicals, and I do not see that big a demand for the bioenergy to ammonia or bioenergy to hydrogen production. It's not that big, at least not that big in Denmark. In Denmark, the whole wind to ammonia is very big. And in the longer run, yes, if there is a shipping company that wants to have its ship just not produce carbon dioxide, then bio oil and all of this does not make sense. Then the only thing that makes sense is hydrogen or ammonia. And then the best way to do is to, from the bioenergy point of view, is to produce a gas that is as good as possible and then have some other people, some other process experts convert it into ammonia.
So thank you. And now the last question, but really a short answer, please, because we are coming close to Paul's presentation. Has there been much interest in the potential for bioplastic feedstock?
It's like way earlier in the in the chain. So bioplastic is more like, first people have to produce bioplastic, then people have to buy the bioplastic, and then people have to get all of it as a waste somewhere, and then we can start talking about it, because we are at the waste level. And first there has to be the demand, and people have to have the production, and not something that is too much talked about. There is still people paying money to get rid of plastic. So so the normal plastic is still a pyrolyzable thing.
Okay, thank you very much, Krishna. Very nice presentation. And if anyone has any questions, you can still write them in the chat during Paul's presentations. I'm sure Krishna will be happy to answer them if you can.